Hello, welcome to this tutorial. Let us solve for x. We have three exponential equations here to solve for x. Let us start straight away with the first one. We have 4 raised to the power root x is equal to root 32. Okay? The challenge in this question here is to be able to reduce these index forms of expression to their simplest form. We all know that 4 can be converted to an index number whose base is 2. Just like 32, we can also convert 32 to an index number whose base is 2. So let's start from there. Okay, so this now will be 4 is the same as 2 to the power 2. But 4 was raised to the power root x. All of that equal to root 32. But 32 is 2 to the power 5. That's the first thing that we see. Okay, now we have power of power law. We apply that becomes 2 to the power 2 multiplied to root x. It becomes 2 root x equal to, we have square root here. Square root means power half. So 2 to the power 5 is raised to the power half. Okay, so we have 2 to the power 2 root x is equal to 2 to the power. We also apply the power of power laws. 5 multiplied to half becomes 5 all over 2. All right. Now we see we have arrived at the point where we have the basis to be equal. If this index expression is equal to this other index expression, then there must be perfect equality at the base and at the powers. At the base, we already have equality. Therefore, we have the right also to equate the powers. And so here we'll have 2 root x to be equal to 5 all over 2. We take this power and we equate to that power. We have now a pretty simple equation to solve for x. So we divide both sides by 2. These 2 cancels there. We have root x is equal to 5 all over 2 divided by 2 is 5 all over 4. And so the last thing to do is to remove the square root over x. To remove the square root, we have to square both sides. So this gives us, therefore, x to be 5 squared is 25 and 4 squared is 16. Okay? So the solution to this exponential equation is x equals 25 all over 16. Pretty simple. Okay, let's look at the next exponential equation again. We have 9 to the power x plus 9 to the power x plus 1 is equal to 270. Okay, the first thing to handle is 9 to the power x plus 1. We know the law. The law of a to the m plus n means it is a to the m multiplied to a to the n. If we apply that law here, we're going to have 9 to the x plus 9 multiplied to 9 to the x is equal to 270. Okay, now we have an expression here in terms of 9 to the x. So to make it look a lot clearer, then we can say let y be 9 to the x, for example. If we replace 9 to the x with the letter y, we're going to have here, we're going to have y. That means we're going to have y plus 9y plus 9y is equal to 270. Okay, so y plus 9y gives us 10y is equal to 270. So to remove this 10, we divide both sides by 10. Okay, so we now have y is equal to 27. Pay attention, we were not asked to solve for y because there's no y in our original question. We were asked to solve for x. So we come back here. It's from this substitution that we'll be able to get the value of x. So we'll replace y with the 9 to the x. So this therefore means that 9 to the x is equal to 27. All right, we arrive at a much more simpler exponential equation. Once more, we carry out the same process that we did over there. Over there, we realize that we could change 4 and 32 to index number whose base is 2. Here, if we look at it carefully, we can also change 9 and 27 to an index number whose base is 3. 9 is the same as 3 squared. 9 was raised to the x, and 27 is the same as 3 cubed. Okay, so this gives us 3 to the 2x is equal to 3 cubed. We have equality of two index expression again. For that to be valid, the bases must be equal, and we already see they are already equal, and the powers must also be equal. So that means 2x must be equal to 3. From there, when we divide both sides by 2, we see that x is equal to 3 all over 2. Okay? Now, let's take the last exponential equation. We have root 7 raised to the power root 24 minus root x equals to 49. Okay, no panic, no matter how complex the equation seems to look like. What we quickly see is that we have base 7 here, and 49 can also be changed to an exponential expression whose base is 7. And so we just carefully change everything into index form, much more readable index form. Root 7 means 7 to the power half. That is root 7. But all of that was raised to the power root 24 minus root x. Okay, it's equal to 49 is 7 squared. All right, so a half multiplied to root 24 minus root x will give us 7 to the power root 24 minus root x all over 2 equals to 7 squared. Okay, once more we have arrived at the equality of two index expressions. This index expression equals to this index expression. The bases are equal, so we also have the right to equate the powers. And so the power here is root 24 minus root x all over 2. We equate to the power this way, which is 2. All right. This is a fraction. We can make this also a fraction so that we carry out cross multiplication. 1 multiplied to all of that, we have root 24 minus root x equals to this denominator multiplied to that numerator. 2 multiplied to 2 is 4. All right. Now we got to this level. We have this radical expression equals to 4. To remove the square root sign, we just have to square both sides. Okay. So root 24 minus root x, we square it, and okay, and we come and square 4. All right, so we have squared the left hand side and we square the right hand side. This square will just come and cancel the square root sign, and so we are left with 24 minus root x is equal to 16. Okay, Remember, we are solving for x. So if we take this negative root x to the right hand side and take this positive 16 to the left hand side, we're going to obtain 24 minus 16 is equal to root x. Negative root x going to the right hand side becomes positive root x. Positive 16 coming to the left hand side becomes negative 16. So 24 minus 16, that gives us 8 is equal to root x. Now the last thing to do, we have to remove the square root sign. The opposite operation of square root is square. And so if we square both sides, we're going to obtain x to be equal to 64.